Hi there. In this short, hopefully short lecture, we're going to organize all of these terms that we use a lot in chemistry, like matter and compounds and elements, so you can kind of figure out which ones make up which and how they all fit together. So let's start out by defining what matter is. I suggest that you stop and write down as much of this as you need to, and then play the video some more. So matter is made up of atoms and molecules. We're going to talk more about the structure of atoms later on. Molecules are made up of multiple atoms. So you can have something be made up of lots and lots of molecules or not very much. We can describe matter as something that has mass, weight, volume, or takes up space. So for instance, the chair that you're sitting in, that's made of matter. But the electricity that you are using to power this iPad, phone, computer, whatever you're using to look at this presentation is not made of matter. It doesn't have mass or weight or volume or take up space. So some examples, and I could have a huge, long 5-hour set of examples that would never repeat themselves of things that are made of matter. It would include mountains, so it doesn't have to be a living thing. Cute little puppies, houses, cars, and of course, yourself. Ha! It's a funny joke. Never trust an atom. They make up everything because everything that you can touch is made of atoms. All right, so let's figure out how all these words start to fit together. Everything is made up of matter. Matter is made up of things that are either classified as pure substances or mixtures. So let's look at that. Pure substances. Go ahead and stop if you need to write all these things down, but I am going to explain them. So pure substances are made up of matter, primarily elements and compounds that have a distinct chemical property. That particular sample of pure substance is always going to behave the same, regardless of what day of the week it is, or whether it's summer, or whether you are experimenting with it, or I am experimenting with it. It's predictable. And all those atoms are made up of the same types of materials, the same combination of protons, electrons, and neutrons. And that's what these subatomic particles are: protons, neutrons, and electrons. So the pure substance, all the matter in that sample, is going to have the same combinations of protons, neutrons, and electrons. We're going to talk more about those particles later on. So if we were going to compare this to something like mixtures, it is the most basic form that we can have that has some kind of a function. And if any of those neutrons, protons, and electrons are removed, that sample is not going to behave the same way. It's not going to react chemically the same way. It may not change state of matter the same way. It just depends on what's been removed. So examples of things that are pure substances, we have elements and we have compounds. Elements are straight off the periodic table. Compounds are chemical combinations of multiple elements. So hydrogen is an example that comes straight off the periodic table. Oxygen comes straight off the periodic table. Those are both elements. And when hydrogen and oxygen bond, they make the compound water. So hydrogen and oxygen both being elements, they can make water and still be a compound. Or they can combine with other things and become mixtures. So mixtures are two substances, and they can be compounds or they can be elements that combine with no chemical reaction. They don't get stuck together. And it's easy or practical to separate them physically. So for instance, if we take the example down here of salt, which is a compound, NaCl, and water, which is another compound, H2O, when we combine them together, they make salt water. Now, we can't just sit there and pull the salt molecules out, but if we heat up the water is going to escape as a gas, and what is left is our salt. So we can fairly easily separate them, and physically, without using any other chemicals involved. So if we were going to compare mixtures, we're going to say that the compounds that we have in the mixtures, remember a compound is a pure substance, they still act the same way. Water is always going to act like water, even if you put it with salt. So let's look at all this together. We have matter, broken down into either pure substances, which are made up of elements and compounds, or mixtures. Let's talk more detail about those things. Take a minute and write these pieces down, or pause in between each line so that you have a chance to understand what I'm sharing with you. So an element, you can identify them because they are located on the periodic table. Fairly straightforward. I don't expect you to memorize the periodic table, but you do have one in this packet, so you can refer back to it. They cannot be broken down into anything simpler without losing their characteristics. So you can break an element down into its protons, neutrons, and electrons, but they do not behave like the element that you pulled them out of. And then they are the building blocks for other molecules made up of multiple elements that become compounds, or molecules that have all the same elements but just become bigger. For instance, oxygen is an element on the periodic table. If you put two of them together, it becomes oxygen gas, which we breathe and use every single day. All right, so compounds are made of two or more different elements, and there are compounds that are made up of many, many elements, and there are compounds that are made up of only two, like water, for instance. And they can be broken down into smaller substances, their elements, by a chemical reaction. So I can't physically separate H2O, but chemically it's very easy to do. They have a defined chemical structure, which means that the elements are organized always in the same way. So for instance, oxygen is always going to be chemically in the middle of two hydrogens. Now this is not something we've talked about yet, and we're going to talk about it later. You can just tuck that in the back of your mind. All right, they come in a fixed ratio, which means for water, you're always going to have two hydrogens and one oxygen. You're never going to have three hydrogens and one oxygen and call it water, or you're never going to have two hydrogens and two oxygens and call it water. For this thing to behave the way it always does, it has to have this combination of atoms. And then compounds can only be separated through the addition of some other chemical to break them apart. So if I were going to compare elements and compounds, elements have different properties than the compounds they may become. So for instance, sodium, that's Na as an element, by itself is an explosive metal when exposed to the atmosphere. So it's a solid. Chlorine is an element as well off the periodic table, and in its natural room temperature state, it's a poisonous gas. If you breathe it in, it'll kill you. However, both of those, when they come together, they form NaCl, which is something we eat every single day. It's table salt. We actually need it to survive. Even though each of those separately have the potential to do you harm, together, there's something that you rely on. So the elements are very different in the compound than they are by themselves. Now we have two kinds of mixtures. We have a homogeneous mixture, and we have a heterogeneous mixture. A homogeneous mixture, the word homogeneous means that it all looks the same. The word hetero means that we have different types of thing in that mixture. And we can see them. So for instance, in this example that I've given you down here, Italian salad dressing, if you shake it up, it all kind of blends together. But if you let it sit for a second, you'll see that the oil and the vinegar layers separate. And any floaty stuff in it settles down to the bottom. Or sometimes floats to the top, depending upon what you put in there. As opposed to milk, now you all know that over time milk can separate, and whole milk is actually a heterogeneous mixture, but the stuff you buy at the store is all the same type of milk, and unless it ages and forms like this, the nasty cottage cheese at the top, is going to be homogeneous. You can't pick out the different components of it visually. Another example of something that would be a homogeneous mixture would be some types of volcanic rock. They all all the components, all the compounds and elements are mixed together, but because it's heated, they all settle equally throughout the rock. Another example of a heterogeneous mixture would be granite. That's that white fleckledy rock. Now, let's take a quick minute to review what these might look like. Our simplest thing that we have out there, it's a pure substance and it's an element. And all the particles in that element look the same. Then we have compounds. Compounds are a combination of elements, but every compound is going to be the same. And it's going to be organized in the same way. So if this was water, we'd have O's in the middle and H's on the side. A homogeneous mixture has multiple compounds or multiple elements in it that stay separate from each other, but they kind of scatter throughout the whole mix, and so we don't pick them out visually. As opposed to a heterogeneous mixture, which is going to have multiple elements and compounds, but they stay separate from each other, either because of density, so one of them sinks down, like we have with the oil and vinegar, or because they cool at different temperatures. We have some rocks where you can see crystal forming in the rocks because the crystal cools at a different temperature than the liquid rock around it. And so we can see stripes forming in some rocks because of that. All right. If you need to review at any point, you can step on back into this lecture, but we are done for now. Thanks.